In this presentation, we will consider the concept of future value. When considering future value, we want to keep the same picture in mind we had with present value. Obviously, these two terms are somewhat related. Present value, future value, that picture being if we had $100 today or $100 sometime in the future, which would we prefer? Typically the $100 today. The idea being that the money that we get today is worth more to us than the money in the future, and therefore if we were to equate these in terms of value, the future dollar's amount would have to be higher than the present dollar amount in order for these two values to be equivalent. That could be due to the value of the dollar going down due to inflation, or to what we could do with the dollar, purchase, get value in this point in time, or invest, increasing the value of the money. For practical purposes, we often think of the future value calculation in terms of investments. In other words, if we had $100 today, what would it be valued at in the future in terms of future value dollars if we were to get some type of return on it? In other words, if we had the $100 today and we were to invest that $100, how much would it be in the future? Note that when we're in the future and we count the amount of money, we're in the future dollar amount. We're at future dollar values. And therefore, it's often useful to think about the future value in terms of application, usually with regards to some type of investment. We have money now. At what rate will it be to get some amount of money in the future? That amount of money in the future is in future dollars. Here's the formula for future value. We'll go through a few different scenarios in terms of how to calculate the future value. We have the formula, we have the tables, we have Excel. We want to know about all of them, even if we prefer one of the methods, so that we know that if we see any of the other methods, we're not talking about a different thing. This isn't a different animal. It's just a different way to approach the same thing, so that when we see that different approach, we then can apply it. We can use our own approach. We can see how things are working. Formula being F equals P times 1 plus I, or interest rate, to the n, or the number of periods. For example, if we consider our time frame to be 1 year, so we have $200 here, what's it going to be in 1 year, or what's the future value at a rate of 10%? F equals, or future value equals, the 200 times 1 plus 0.1 to the n, or 220. We can also consider the calculation in this format. If we start off with $200 and we say times 10%, 200 times the 10%, it's going to give us $20. The 200 plus the 20 will give us to that 220 at the end of this time period at the future value. Now, if we think this is a 2-year time period, then we would have the $200 we are starting with times 1 plus 0.1 to the 2, and that will come out to F, or future value, 242. So if we started with $200, 2 years later, we've got the 242. Their value, the 242, is valued at future value. And again, what does that mean? It means it's actually, if we were thinking about an investment, we would consider we actually have $242 2 years from now. That's in future value terms. Those are in future value terms, not in present value terms. And again, the 10% that we're getting might be a good investment. We might say that's a good investment. We earned 10%. It might be over and above what we think the rate of inflation is. The rate of inflation might be something less than the 10%. So when we consider present value and future value in terms of equivalent dollars, remember that we're usually talking about the idea of inflation, which is usually in normal times in the US 1 to 5%. If we're thinking about the investment purposes, often take into consideration opportunity cost, what would be a good investment, then we're considering the rate of return on the investment. So this 242 that we're considering out here, if we're considering this 10% then to be an investment type return, is what we would actually have in future value terms. If we want to compare it to what we had at the beginning, we may need to present value it in terms of purchasing power, which might be at a rate of, say, 5% or 3% in terms of purchasing power. So the types of terminology that we use with the future value and the interest rate can be a little bit confusing when we start to consider the types of investments or the types of ways we use the future value formula. Now we can do our calculation just to double check this. That we started off and we left off last time at 200 times 10%, $20. That's 220 for year 2. If we start at 220 times 10%, that gives us $22 $220 plus $22 is the $242. So that's another way we can think about how we get from the starting point to the future value 2 years later, the $242. The other way we can calculate this, other than a formula, is with the use of tables. The tables will often be used in test type questions at schools because it allows us not to have to use the formulas, and it allows us to not use complicated calculators that maybe institutions don't want during test time. And therefore, the tables work well and are close to practice. In practice, of course, we probably would use Excel, I think, is the best format to use in practice. So remember, there's usually 4 tables. If you're considering future value, you can eliminate the 2 present value tables. You look at the 2 future values. Are we thinking about future value of 1 or an annuity? And here we're thinking about the future value of 1 because we don't have a series of payments. We have the interest rates on the top. We have the number of periods on the left. The periods could be years. They could be months. Typically, we're thinking about years, but the periods don't necessarily have to be years. They need to, however, coincide with the interest rate. So we usually see the interest rate or whatever rate we're using at the yearly rate. So if you're talking about a monthly rate, then and you want to coincide with the number of periods that are months, you'll have to take that yearly rate and divide it by 12. So in our case, 10%, we have 2 years, that's 1.21, 1.21. So if we see our calculation, we have the 200 starting at, we have the 1.21 from our table. That gives us our 242. That's the second way that we can calculate it, often used in testing situations. In practice, we will typically use Excel. Once we know what the formula is, we can solve for any missing variable. So obviously we can use the formula to solve for the future value if we know everything else within the formula, or if we know the future value, we can use the same formula to solve for the interest rate, or we can solve for the number of periods. We can solve for whatever unknown is there given the information that we have. We can use that and solve for that using algebra. We can work with the tables to do that. We'll show how to do that with Excel as well, and that's going to be the most practical thing to do within practice. In other words, you really want to know the future value function, you want to know the present value function, and then you can solve for different items that might be unknown, such as the interest rate or the number of payments, with those functions using a feature called the goal seek function. So first we'll go through the process in Excel. This is the third way that we've looked at. We looked at the formulas, we looked at tables. Now we'll look at Excel, the most practical format in real life. In practice, gives us a lot more options, a lot more flexibility to work with these types of equations. So we find this formula in the Formulas tab. We've got the function library group, and then we're going to go to the insert function. This is going to be the way that we can search for functions, and it's going to give us a dialog box that we can enter into that's helpful oftentimes when we're getting used to it. We can search for the future value. It's going to be FV. You might want to just start to remember future value is going to be FV. You'll see it represented as FV because it's going to be common, probably because of the use of Excel. So here's our function dialog box. Here's where we're going to enter the data. This will help us to go through the data. We'll start off with the rate up top. So the rate up top is in B4. So we have cell B4, and that's going to be the 10% or 0.1. It'll give you basically what is in that cell over here. And then we have the number of periods. That's in cell B2. So in cell B2, we have 2. And cell B2 gives us 2. The number of payments is 0. That's the tricky piece. This is 0. But this is nice because note that the future value formula, the FV formula function, will be the same for the annuity. It will be the same for the single payment of 1. And that means we only need to know one function once we understand the difference between those two. And if we can combine that with the goal seek feature, we can also solve for different factors within the equation with just this one function as well. So if we can understand the FV function and the difference between the using of the payments versus the present value, we're doing quite well. So we have the payment is going to be 0. We would only use that if it was an annuity, if it had a series of payments rather than just one payment at one present value payment. And then we have the present value. Notice it's not boldened because it's not going to be used in every kind of calculation. It would not be used if we had an annuity calculation. It will be used in this case because we're using the present value of 1, that being the difference between these two. That's going to give us our answer of the 242. So here's our 242 that it would result in through this function. Now we can also see this function in terms of if we wanted to type it in. This is the actual formula that we'll show. It's going to be equals. I usually put a negative before the FV, or else it'll give a negative number as a response. The negative before it will flip the sign to a positive. FV brackets. Then we're just going to follow our little dialog box down here. So it says rate. Rate is going to be here. That's picked up in B4. So B4 is the rate. Comma just means that it's going to go to the next function, which is the NPR and PER, which is the number of periods. It's in B2. So that's going to be B2, which is 2 periods. And then comma, and that's going to give us our next function, which is the payments, which is 0 because it's not an annuity. So we just put in 0 manually, then comma, and the next item is going to be PV or present value, B3. So that's in B3 or the 200. And that's what it would look like in terms of just the formula view of this. Now also note that we can figure out if we have this formula, this function, this form, f equals p times 1 plus I to the n, we could solve for f if we know everything else. But if we have everything but the interest rate, then of course we can solve algebraically for the interest rate. Or if we have everything plus the number of periods, we could solve for the number of periods. We could do this algebraically, but we can also do it with Excel. And the way we do it with Excel is we can use this goal seek feature. So the goal seek is going to be over here in the what if analysis, and then you would go to goal seek, and it's under the data. So data, what if analysis, goal seek. And if you want a more detailed example of this, we'll have demonstrations within Excel. But the idea then being that we could only know, or we only have to know then, the future value function, and we then can solve for anything that's an unknown here. So if the only unknown is this item or the number of payments, we can use the same function and not learn 3 different functions, use the same one. We can use goal seek to figure out the unknown variable. So we won't go into the detail within the PowerPoint. So if you want more details, some examples of that, we'll have example problems that will actually be in Excel. Just note what we want to do here, of course, is to basically memorize the minimum amount that we need to get what we need to get done. That means we need to know the present value formula, and we need to know the future value formula, and that'll take care of the present value of 1, present value of an annuity, future value of 1, future value of an annuity, and the unknown if we know everything else with the use of goal seek, including the interest rate and the number of payments.